Hello, I'm Maverick with OwlKnightsMedia, and today we're going to continue the Making the Main Game scene part of the Dodge the Creeps official Godot Make Your First 2D Game tutorial. Ooh, that's a mouthful. Last time we left off with creating the enemy, which they call Mob, and this time we're going to be making the main game scene, so finally everything's going to start to come together. Let's go ahead and dive right in. The docs have you create a new scene, and they use the top level node or scene, and they're not using 2D because they don't want all the functionality that comes with it, so we'll go ahead and follow suit. And they rename node to main. So forgive me, I'm going to be saying the word main a lot during this part of the tutorial. I kind of wish they had just called it game to help distinguish between the main scene that Godot treats versus this main node. You'll see what I mean shortly. Okay. They then go ahead and have you click this other icon, not the plus, but this other icon which instantiates an existing scene as a child of your scene tree. So you click that and you choose something that already exists. In this case, we're choosing player. And it adds a player as a child of the main scene. If we go over the 2D view, we can see that the player is now on the scene. You could also drag and drop an existing scene, and it will do basically the same thing and create an instance of that scene. So think in terms, instances would be like you have this cookie cutter that you use to create individual cookies on a cookie sheet. Each cookie is an instance that you've created from the scene or the template of that cookie cutter. I know it's a stretch, but it's the best one I've got right now. So we'll remove that duplicate. It was only for demonstration. And continuing along with the tutorial, they have you do several things. So one of the first few things they have you do is add a timer node, this time as a child, so you are clicking that plus sign. And they make 3 of them. So I'm just going to click this one and press Control D for duplicate. A couple times there, now I have 3 timers. They also rename each timer, so we'll go ahead and do that. Mob timer, let's see, they have score timer, and then the last one is start timer. The spelling and capitalization is important, as we'll be referencing these in code with the $sign, so make sure that if you're having issues that you double check spelling across the 2. Okay, and for each of these they also have you go into the inspector portion and set different wait times. So for the mob timer, scroll down a little bit, they have the mob timer at half a second, so 0.5 on the wait time. The score timer they actually keep at 1, so we'll leave that alone. And for the third timer, the start timer, they set it to 2 seconds. Something also different with the start timer is that they only want it to run once when it's invoked, so they click this one-shot checkbox. What that means is normally a start timer will go, let's say it's 2 seconds, right? It would go 2 seconds, fire off its signal called timeout, and then in 2 seconds, timeout, 2 seconds, timeout, and so on and so on. By clicking one shot, it'll start, 2 seconds, timeout, and then it just stops running. And that's what they want for the start timer. So we go ahead and click that as they indicate. Another node that they add to the main scene, click the plus sign, is called a marker 2D, which they're using to track where they want the player to spawn. So you could move this around to wherever you want your player to spawn. They actually have you put this in manually as opposed to using your mouse. So over here we can see that it's already changed its position on your transform. And they specify that you can put in 240 and 450. And so that's where the player is going to spawn. So when we go to test this scene, we want to make sure that that's exactly where the player starts. And we have to code that, so we'll get there. Next up, they say time to code. So they have you create a main script. And I'm actually going slightly out of order, but that's okay. We can make the main script, and then something else they had us do, which I kind of glossed over, we're going to take a step back and do it, is add more nodes to this child as children of main. And it's going to be a Path2D. Think of it as literally a path. And then a child of that path So with the Path2D selected, we're going to add a PathFollow2D. And we can see that child relationship here. They rename them. So it's going to be mob path, I believe. And then they rename this path follow as, I think, mob spawn position. Let me just double check. Mob spawn location. Mob spawn location. Again, you can name it whatever you want. Just be sure you adjust your code accordingly. Let's take a moment to explain what's going to happen here. So this mob path we're about to define as the outline of the game screen. And we want this mob spawn location, which is a PathFollow2D node. It's going to go along that path we define, a little rectangle, and it's just going to travel it. So what we're going to end up doing is using code to put it on a random position of the path and then start spawning enemies from that position. It'll make more sense when we get there, but that's what's going to happen. So we have this path made, but we haven't actually defined the path. So with the mob path selected, we hit this little icon called add point. We're going to activate these filters, if you will, that snap to grid and show the grid. And something I like to do that I don't think was in the tutorial is make the player invisible so that I can see what I'm working with a little bit more fine-tuned. With the select mode activated, I'm going to then start clicking. Again, this is only going to work if you had add point first. We're going to start, whoop, I missed. Good thing we have the node selected. Let's do that again. There, that looks like the true corner. Then we're going to get the other corner of the screen. And we can see the path starting to appear as a line with chevrons indicating the path direction. We'll get the next corner. Second to last corner. And because this is so well defined, we can trust that instead of clicking that next, like where you started, you're going to go ahead and click this close curve, which will draw the path with the chevrons here. So let's watch that happen. And there it is, close the curve. Excellent. Okay, and that's all we need to do for defining the path, and we know that this mob spawn location node is going to traverse that path in the direction of the path that we defined. So on that note, it is important that you go clockwise with your path definition like we did, from the top left to the top right, down, and so on. Because if you don't, the code that they wrote is designed around that notion. If you were to, say, have done it backwards, counterclockwise, instead of coding for enemies to go into the screen, they'll end up going out of the screen, which is obviously not what we want. Speaking of code, I think we're ready to actually start coding this time. I was a little jumping the gun, ready to get into it. All right, so we should have everything we need in the scene. We created a script for the main scene. And let's just make sure I'm not hopping ahead too far. Okay, good. We're fine. Continuing on, they add an @export, which will make this available outside of this scene in terms of accessing with code. And it will also add onto this node the variable we're about to define in the inspector portion. So here we only have resource at the moment. Let's go ahead and keep defining this. We're exporting a variable that we're going to call mob scene. And what this syntax is, with the little colon and pack scene, is we're specifying the type of thing that mob scene should be. What this allows us to do, if we select main, go to the inspector, is when we try to select one of the scenes in here that we added as an export, it will make sure that we're actually selecting a type of pack scene. So for sake of argument, I'll grab this mob GDScript, and you can see I can't drop it there no matter how hard I try, because we've typed what it should be. And what should be in there is this mob scene and not the mob GDScript. So we'll go ahead and drop that in there. We can see a little preview, so that looks like the enemy to me. All things are good. Next up, they declare a variable called score, which is what we're going to use to reflect the score on the UI that will be made in the next portion of the tutorial. Simple enough. And I'm going to get rid of the delta for right now. If we need it later, we'll add it. And I'm looking at the instructions just to make sure I don't miss anything. This all seems appropriate. Load the scene. Okay, They're just giving you options. Next, they have you select the player instance, and they want you to go to the node signal area. Back in the first part of the tutorial where we made the player, we also defined a custom signal called hit. So they want us to double click that and connect it to this main scene, but they renamed the default method in this case to game over. And then you can go ahead and connect as usual, because that's what's going to happen when the player gets hit. It's going to release the signal, and then the main game scene is going to go, okay, I heard that you were hit, we're going to end the game. So after that, they add some code to actually do that. So they're going to reference with the $sign one of the children of the main node called score timer, and we already made that. And they're going to invoke stop, which is a built-in method on timers. Similarly, they're going to also stop the mob timer. They're doing this because the score and the generation of monsters doesn't need to continue if you just died, right? The game's over. Easy enough to understand. They have you define a new function that isn't directly connected to a signal, and here we go, and it's called new game. I highly recommend you guys type out things as you do tutorials. It gets you much more familiar with the language you're using, and it gets you familiar with caveats or things that you might not realize you're prone to do. For example, I'm not used to adding a colon at the end of function declarations because of other coding languages. So it's really good practice, even though you could copy and paste. All right. They take the score we defined at the top of the file and they set it to 0. Why? Because this is a new game and that's what the function is going to do. You're starting from scratch, your score should be 0. Next up, they say, take the player and we want to invoke start on the player. Now, you guys know that the player is clearly not a timer node, but it has the start function. So as a quick refresher, that player scene we defined in the first part of the tutorial has a custom method called start. Let's go take a look at it real quick by going into the player scene, or the player script rather. And at the bottom of the player script, we have this start function. In Godot, they like to use this implicit where if it has an underscore at the start of a function name, it's supposed to only be used by this script. And if it doesn't have an underscore at the start, like the start doesn't, underscore or not. If it does not have an underscore, then it's meant to be used external to this script. And that's exactly what we're doing by calling it from the main script, which we'll get back to in just a second. Normal flow of development would be good to refresh ourselves on what is this going to do. It's going to take the position of the player and it's going to set it to whatever position we pass as an argument to this method start. So when we invoke start, we're going to have to pass it a position. Okay? Then it's going to set the player to be shown. In the ready function, it's hiding, as a reminder up here. And then the last thing it does is it re-enables the collision functionality of the player so that if something hits it, right, it actually collides, gets detected, and emits the signal that we expect it to emit, in this case hit, which we also defined up here as a signal for player. So with that refresher out of the way, let's get back to the main script. We invoke start. We know we need to pass it a position because that's a required argument. So we're going to reference the start position marker 2D node that we created, and whatever its position is, that's where we want the player to start. Next up, they take the start timer because we're making a new game, and they're going to actually start it, which this start is built into the node type. So that's going to run for 2 seconds as we set it to, and then it's going to do something, right? So the next step they do is, okay, we need to set up all the connections for each of the timers so that we can react to when those timers fire their timeout signal. So that's the next part of the tutorial. They have you select each of these timers. You go to the inspector node area where it lists signals, and you double click the timeout and connect it to the main function. They stop renaming methods, so it's a little bit faster. We'll do that for all 3 timers, connecting them and their timeout signals to the main script. Now we have all 3 of those. I would rearrange these because the mob timer is the most complex and doesn't happen first. So this is not part of the tutorial. I just prefer to have this one defined first. It just makes more logical sense to me. And the icons will update in just a moment. And the score timer I'm also going to put above the mob timer just because it's much more simple, as you'll see here in a moment. So on start timer, which we know is going to happen when the new game happens, we want something to happen, right? So they have code in place that we're going to walk through in just a second. On start timer timeout, we get rid of the pass and we reference the mob timer. And that's a timer node, so we start that one up, and then we're going to start on the score timer as well. Score timer.start. So all that's happening here is after 2 seconds, to give the player time to like see what's happening, we're going to start the timer that makes monsters appear, and we're also going to start racking up a score based on a timer. So that's the next part. That score is the logic in the score timer signal. We're going to take the current score and we're going to plus equal it 1, right? So if it's 0, it becomes 1, 1 becomes 2, and so on every 1 second, every time that particular timer times out. And then we have the meat and potatoes of most of this lesson, which is how to spawn the mobs, make them random, and all the stuff that's going to happen here. So we're going to look down here. They talk about what they're intending to do. They're going to make a monster. They're going to pick a value between 150 and 250 to represent how fast the monster is going to move. And then they're going to add that monster to the scene somewhere along the monster spawning path, or the perimeter of the game window in this case. Okay, I know I said you should absolutely type this every time you do a tutorial. However, I'm presenting this in a video format and I respect your time. So I'm going to copy this and we'll walk through it together to make sure it all makes sense. So let's go ahead and paste that in there. All right, now let's dissect what's happening. Some of it's very easy, some of it less easy. So the first thing they do is declare a mob variable that we can alter for convenience, which takes the mob scene. If we scroll up, we know that that's that variable we dragged the mob onto and defined. And we instantiate. So I talked earlier about how you can instantiate players onto the main scene, and we did. But you'll notice that we never instantiated any enemies. And that's because we don't want them there when the game first starts. We want them there based on a sequence or a timer, right? So every 1 second, now we want that monster to be added to the scene. So that's why we have to instantiate a new one, because it's not already in the scene. Next up, they leave comments, so this helps a lot. Choose a random location on the Path2D. Path2D is that mob path we had. So they declare a variable so that we can keep referencing it. And something you'll notice here is this /, and that's because that mob spawn location that we're trying to declare is a grandchild of main and not a child, which means if we didn't have the prepended part and just tried to shorthand it like this, it's not in scope for this script. So that's all that's happening there. It's any file system type thing. You need to dig down a level if it is a grandchild. Next line is we're taking that location, or that mob spawn location, and we're saying choose a random float or random integer value between 0 and 1.0. And we're going to treat that as between 0% and 100% of the outline. To reiterate, we drew a path, and that mob spawn location, which is a path follow node, is going to travel along that path. And we're saying, hey, your progress along the path is somewhere between 0% and 100%. And we're just going to randomly decide how much. Whoops, let's go back to the script. So that's what that's doing. It's saying choose a random point along the path, effectively. All right, fine. Set the mob's direction perpendicular to the path direction. This is where we're going to have to do a little bit of better explaining as to what's happening for those that aren't familiar with circles, degrees, and what this actually means. So let's break it down bit by bit. Mob spawn location is the thing that's following the path. It's going to be somewhere along it randomly. And its rotation you can treat for this discussion as the way it's facing. And if we go back to 2D, you can see these chevrons all kind of point in a, relatively speaking, forward direction along the path. So picture that you're traveling along this path. You're the mob spawn location. So you're just looking forward and you're just following the arrows. But when we create an enemy, we don't want the enemy to be facing along the perimeter of our game screen. We want them to face inwards towards the game screen and then go that way. So because of that, if I'm facing straight, picture it as I need to turn right? I need a 90-degree perpendicular turn to go towards the center instead of just along the outline of the game. Back to the script. All right, now they're doing that by taking their current facing and adding what equates to 90 degrees. So I'm going to try to explain this. So let's picture a circle or a compass. I like thinking in terms of a compass because it has degrees. 90 degrees would be perfect perpendicular, right? I also like compasses because I used to fly. So you have this circle, and that circle is represented by 360 degrees. 0 to 360 is north, or effectively north. And then 180 would be south, 270 is west, and 90 degrees would be east. So what does that equate to in what's known as a radian? This is what that pi divided by 2 thing is. It's an expression of degrees in radians, or expression of a circle in radians. So that would be pi. It's actually 2 times pi. If you did a quick Google search of, what are the radians of a circle, a full circle is 2 times pi. So with that premise in place, then we know that 180 degrees, or half a circle, would be half 2 times pi. So let's go ahead and write that down as a variable. Half circle, which is 180 degrees, equals 2 pi divided by 2 is pi. So continuing that train of thought, half of a half circle, so a quarter circle, which would be 90 degrees, or east, if you want to think in terms of a compass, would be half of that half, right? So pi divided by 2 is 90 degrees. And that's how they got here, right? So they're facing a direction. They want a perfect perpendicular, which is 90 degrees. And that's where that pi divided by 2 comes from. Because we're about to talk about the next few lines, I'm going to go one step further so that it makes sense when we get there. And we would say like 1/8 of a circle, so half quarter, which in degrees would be half of 90 degrees, 45 degrees, is equal to pi divided by 4, right? So we're just going half down this list, and that's where these numbers are coming from. These are the degrees, if you can think of a compass, that it equates to, and the angles associated with it. So knowing that, we don't need these variables. This is all me, not the tutorial. I just want to make sure you guys have a basic rough understanding of this. I'm not a mathematician. Apologies if I made an error. Okay, so that's what's happening. That's what they mean by setting it perpendicular. They're using this thing called a radian and it's very popular in Godot. I do recommend trying to get used to using pi, but let's move on for now. Next up, they set the monster position to the position of the mob spawn location, right? So we chose a random spot for the follower on the path to B. Now let's put the monster there. That's all this line is doing. Then they want to add randomness to the direction. And so as a reminder, the direction is that perfect perpendicular. So if you were on the bottom of the screen, for sake of argument, your perfect perpendicular would go straight up in a straight, perfect line. And so what they're doing is saying, we want to take that and add a little bit of randomness to it. So random float range. So the first argument is the baseline. So like from this to the second argument, from this to this. And so they're saying negative pi divided by 4, and we know that's 45 degrees. So negative 45 degrees, somewhere in the range of that, all the way to positive 45 degrees. And that's our randomness value. that we're adding on to that perfect 90 degrees. So visually, if you started at 90, we're just adding a little bit of randomness, plus or minus 45 degrees, so that the monsters come out in a more natural looking way. Mob rotation, we're setting to that direction, basically saying, hey, monster, here's your position and the way you're going to fire in towards the center of the screen with a slight randomness to it. Next up, they have velocity, and that's because rotation and direction, that's all nice, but we need to like go, right? We need movement from the enemy, so we're declaring a velocity, which is a vector 2. Just think, x, y type thing. When you have a vector that's only one value of those two, a vector 2, then you can kind of just treat it as either a direction or a speed. And they mentioned earlier in the tutorial, they wanted a speed between 150 and 250 pixels. So they're choosing randomly in that range as effectively the speed at which they want to go. So the next line, sorry, we're almost there. We're almost done. They're setting the linear velocity, and it's called linear velocity because it's only moving along one axis. When we were making the player, we want the player to move in both axes, X and Y. These monsters are just going to kind of go in a straight line at whatever speed and angle we set them at. So that's why we're setting the linear velocity, and that's going to be equal to the variable we just defined. And this rotated function takes in an angle. So let's look at the docs real quick. Rotated of a vector 2. We'll pull that up. Here it is at the top. It returns the result of rotating this vector. So it's vector dot rotated, right? So whatever that first vector is what's getting rotated by the angle in radians. Another good reason to use radians is you don't have to keep converting to make the game engine happy. So that whatever that argument is, it's an angle. So let's go back to the script. So direction, despite the naming of the variable, it is an angle. And we can see that we've added plus or minus 45 degrees of variability, 45 degrees, right? Angle. So we pass in what is effectively an angle to the rotated, which needs an angle, and it takes our velocity and it does magic and makes it go, okay, I know the angle and the speed, and here's your new velocity. So that's what's happening. The last line is a lot easier to digest, which is we have the monster, we have its velocity, we have its position, we have its facing, all this stuff. Now we need to actually add it to the game, because right now it just kind of exists in the code and not on the game screen. And to do that, we invoke addChild, which will add it just like that player is in the left-hand side. It's a child of main. The code is going to add it during runtime as a child of main, because that's the script we're attached to. And it's going to add what? The monster that we just instantiated in this method. I know that was a lot to get through. Hopefully we moved quickly enough, but slow enough to get the major concepts. I'll go ahead and remove my custom code just so we stay in line with the tutorial. Save, and I believe the next thing they do is they test the scene by adding that new game function into the ready that comes baked in by default. So we'll go ahead and invoke new game. I'm going to save. Now I'm going to press F5. If you've been watching my tutorial videos, you'll know that I kept saying F6 to run this specific scene. So if I press F6, it will run, or it'll try to run. Obviously, there's an error in the code. I'm specifically going to press F5, which will try to run the main scene of the game, as opposed to the currently selected scene. If you've never chosen the main scene, it will prompt you to choose it now. So we'll go ahead and do that. Select main scene, open that. Again, it'll crash because there's clearly an error. We'll take care of that in a second. If during prior steps in the tutorial you had accidentally made some other scene like the player or the mob the main scene, that's okay. In the file section in the lower left, you would just right click whatever scene you want to be the main, and it'll give you an option to set as main scene. I'm not going to do that because we have the correct one selected. Now, I have a bug. Let's figure out what's happening. It's probably just a typo. So invalid index, it says this is good training. we get an error report. It's in the main GDScript at line 15, and it's saying at function new game. That must be the one that's causing the error, and then it tells us that the position on null. So this position is not defined. And I talked about we need to make sure that everything is spelled the same way. So I'm going to presume that that's what's happening here. So start position, if we look over here, there's nothing called start position. And let's go back in the code. I clearly have a typo, and we're going to fix it in just a second, but this is a good learning opportunity. So we're going to find score equals 0, and there we go. So this says start position dot position, but I don't have a start position in my file explorer or my node scene selection here. So clearly I forgot to rename something that the tutorial expects to be called start position. Now I can kind of guess what it's going to be, but let's go back up and we're going to search the tutorial for start position. And here we can see that they've renamed that marker 2D to start position. And that's the problem here. I haven't renamed it, so this is a good example, making an example out of myself, where the naming is very important if you're going to be doing these implicit references. So I'm going to double click that and just rename it to start position. And that should fix everything. Let's press F5. And there's the game. You can move the character. We see enemies spawning relatively randomly around the edges of the screen. They're coming in. They have different animations, different speeds. So everything seems to be working nicely. When the hit signal fired, we clearly got that game over because the monsters stopped spawning. If that mob timer, let's close this. If this mob timer hadn't stopped, then we'd still be firing everything that happens when it keeps going. We'd still be seeing monsters entering the scene. F5 again. So they're coming in at plus or minus 45 degrees. Great. Now, as soon as I get hit, you see all these monsters spawning, different speeds, slightly different angles. Let's get hit. No more keep spawning. Everything's working as intended. This is wonderful. So that's the end of this part. Let's just double make sure. All right, so the last thing they do actually is they have you remove the start game from the ready and replace it back with pass. And that's because the next tutorial section is going to go through and do more stuff. And they're trusting that everything works so far. So we're not going to have the ready function fully fleshed out. That concludes this part. Let's do a sneak peek at what comes next. And the next tutorial section will be the heads-up display, or HUD as many people will call it. And what that's going to do is add UI to the game. Because if I start the game right now, not only will nothing appear because I'm not invoking start game, but even when it was appearing, we didn't have like a start game. Things just started happening, right? Monsters were coming onto the screen. Thankfully, the player was starting in the right position. But we need a screen that says, hey, do you want to start the game? We also need to add things like the score tracker. There was no tracking of that. So there's a lot more to add as far as visuals. But this is really cool to see the game coming together finally. So that concludes the main game scene part of the tutorial. Thank you very much for staying with me. Again, I'm Maverick with OwlKnightsMedia, and we'll see you in the next one.